According to continuous of series of digital electronics, now we are going to discuss about the different types of gates. So as I said that these are the basic gates. Okay, this basic gates is nothing but what and or not. These are basic gates. Okay, arithmetic gates is nothing but XOR and XNOR. These are nothing but arithmetic gates. And we have universal gates. In universal gates we have NAND and NOR. These are main gates. Okay, what is an AND gate means? AND gate what going to be happen? This is the real shape of an AND gate. Okay, so it will not be like this. We have like some transistor like this. Okay, we have some ICs. Okay, like this. This is a shape of AND gate 74 something, one number will be there. That is an number of an AND gate. Okay, so but in shape we will discuss in this manner. So this is an AND gate. So what going to be happen, the functionality of means y equals to a into b. This like in multiplication. So a b means, for example, if I have two switches, for example I have two switches in my hand. So what can I able to, I can able to turn off the both thing, one side. I can able to turn on only one switch. Okay, I can able to turn on another switch, I can able to turn off another switch. Okay, if I can able to turn off both turn on the both switches. So these are my possibility when I have two switches. If I have three switches means 2 power cube 8 combinations we will get. If I have two combination means two switches means 2 power to 4 combination we will get. So here you can observe that this is 0 1 2 3. Okay, now y equals to what going to happen? 0, because y a into b what going to happen? 0 0 0 and 1 we will get. This is nothing but AND operation. Okay, so what is the, we have control input. For example, I need to disable this gate. How I can able to disable means I will give 0, then this gate will always be in disable only. Whatever input you will provide, for example you maybe provide something input 1 0, I don't know, whatever you provide, I am disabling the gate. If I apply 0 to one of the thing means so I don't want to consider another input, so that will be in that will always 0 only. So that is, if I want to disable this gate means I will give one of the input as 0, so then I can able to disable that gate. Okay, so that is not AND gate. So for example, if I AND gate means all the inputs of AND gate output has to be 1 means if all the inputs has to be 1 then only output of an AND gate will be 1. Okay, so for example 0 into 0 0 into 1 1 into 0 1 into 1, what going to happen? 0 into 0 0 only. 0 into 1 what going to be happen? 0 only. 1 into 0 0, 1 into 1 1 only. So that is nothing but operation of AND gate. So if I want to disable means I need to give 0, so that the gate will be disabled always. If I want to enable this gate means what I have to do, I need to provide a control input. We have control input. So if I need to disable this gate means what going to be happen? A control input I will give this as a 0, so then always my gate will be disabled. Whatever the inputs you will provide, I don't want. So my control input is 0, so that output will be 0 only. If I need to enable my gate means then you have to provide input as 1. So according to the inputs you have been applied, if you apply 0 0 means based on that what has to 0 only will come, 0 1 because it is already 1. Okay, so 0 1 means 0 only will come, 1 0 means 0 only come, 1 1 means the output going to be 1. Okay, some functionality has been happening inside, so you will get something according to that. We have some transistors over here that are described in that way. Like if I want to describe an inverter, for example how we will design an inverter. So let's see over here. For example, like in CMOS construction how it will be there, we can see. Now what going to happen? This is nothing but we know that PMOS, this is NMOS. I am taking as an input, I am giving an input over here. I am supplying like VCC, nothing but 1. Okay, 5 volts we have to give. Anything we are given like power ground, either VCC only. So this is nothing but ground. Now what I have to do? If I provide input 0, what going to happen? PMOS will actively, whenever you are apply 0 to this PMOS, this is going to be on, you are taking the output from over here. So if you are providing 0 over here means, so 0 means AND gate will disable, this NMOS will disable. Okay, NMOS will going to be disable if you are applying 0. Whenever you are applying 1 only, this NMOS going to be work. If you are enabling this as a 1 means, then it is going to be disabled. If I want to enable this PMOS means, I will give 0, so that what going to happen, you are giving 0, but what going to, this will enable and this will act, this output will come. So what we have 5 volts, nothing but logic high. Logic high means is nothing but 5 volts, so it will give 1 as an output. Okay, that is nothing but output is 1. So you are providing 0 but you are getting 1, so it is like inverting of that thing. Okay, so if you are provided 1 means, what going to happen, this will be disabled because this PMOS will active high to 0, but you are providing 1, so this 1 will goes over here. So but you didn't getting any VCC over here, so what going to happen, this will connect to the ground, so that we will having logic low, so which is going to be 0 only. Okay, so this is the thing, like this inverter has been designed. So same way AND gate also will be designed in this way only. How we will able to design this AND gate means, like to NMOS we can use. Okay, we will take the output from here. Okay, why? So what going to be happen, whenever you are applying 0 0, what going to happen, by using NMOS only I have designed. Okay, you can use PMOS and you can able to use a CMOS architecture also. CMOS architecture we have to use both NMOS and PMOS, but now I have been used NMOS only over here. If you are applied, as I said that NMOS will work whenever you are giving input as a 1. Okay, so if what going to happen, if you are providing input as a 1, so this will first we will see unfunctional. If you are providing 0 0, both will be off only, VCC will not connect, so till output will be 0 only. If you are providing 0 1 means, what going to be happen, if you are providing 0 1 means one of the switch is off, so we cannot able to get VCC over here, so till output will be 0 only. Now what going to happen, 1 0 I am providing, but I am disabling, up to here you will get the VCC, after that you cannot able to, because this is disabled, so you will till 0 only. Whenever you are providing 1 means, then connection will be established and it will drive the output, so y equals to, we will get 1. So in this way we can able to design AND gate also by using NMOS. Now what we are going to be do means, like this is nothing but AND gate, how that inverter will going to be work we have seen. Now what is NOT gate? NOT gate is nothing but this is an inversion of operation. So like if you are negating the thing, for example if you are applying 0 means you will get 1, if you apply 1 means it is 0. So this is nothing but inverter. We can also inverter we can call this inverter, and also we can call this as an inverting buffer also we can, and also NOT gate also we can use this, and all name inverting buffer. Okay, inverter, inverting buffer, NOT gate, we can have different types of names. Now what we are going to be see means, if you are providing 0 means 1, 1 means 0, y equals to a bar, this. Okay, if you are providing a means output we will get a bar. So if you are providing for AND gate, y equals to ab. Okay, OR gate, now let's see OR gate. Okay, now in OR gate what going to be happen, so inputs, like if you are providing ab means y equals to a plus b. So this is nothing but OR gate, a b 0 0 0 1 1 0 1, these are provided. As I already told that if I have 2 switches means I can able to perform 4 combination. Either I can able to turn on the switch, turn off the switch, either I can able to turn on one switch, or either I can able to turn on another switch, I can able to turn off another switch. Now in our operation what going to be happen, pen means it's like y equals to a plus b. Okay, a or b, one of the input has to be 1 means, then output going to be 1 only. If one of the input is 1 means, always it has to be 1 only. So what going to happen, 0 1 1 1. Okay, you can say if you are adding 1 means you will get 2 now. So why in digital we have, whenever you are going to get 1 plus 1 in OR gate means you will get, because at least one of the input has 1, then output defaultly it will be 1 only. It won't don't want to check all other, at least one of the input is 1, so output going to be 1 only. Okay, I need to disable this gate means what can able to do means I can able to provide 1, so always it will be 1 only. So I am disabling this gate only. Whenever I am doing what, if I want to enable this gate means I control input I can able to give 0. So what going to be happen if I am providing the control input 0 means, then based on the input, whatever the inputs you have been applying 0 0 or 0 1 1 0 1 1, based on that you will get an output. So that is nothing but based on your control. If your control is 1 means always default it is going to be 1. If control input is 0 means based on the inputs you have been providing over here, so that output going to be generating according to that condition. So y equals to a plus b, this is the thing, and this is the nothing but symbol. This is not actually that we are imagine like we make too convenient. This is the symbol of that gate, like that we have discussed. Okay, so now we have discussed the basic gates, 3 gates. Okay, if OR gate means if one of the input is 1 means we will get output as a 1. Okay, now we can able to see arithmetic gates. In arithmetic gates what going to be happen na? We have, as I said, that XOR and XNOR, these are my arithmetic gates. Now what I have to do means, this is XOR gate. XOR gate is nothing but it will looks like this. Okay, this is my XOR gate, it is XNOR gate. Okay, this is symbol of XOR gate. But actually what going to happen na, XOR gate means what going to be happen, A XOR B. Okay, this is A XOR B, this is XOR operation. Now what going to happen inside, it will not be like this. Okay, inside this thing we have another like A bar B plus A B bar. What going to be happen na? So this is structure. Okay, inside A B plus A B bar. Okay, now what going to be happen, this in this way we apply. This is like odd one detector. If you are given say A B you are giving, so 0 A B 0 0 0 1 1 0 1 1. Now why, what going to happen, it is going to be odd one detector. Okay, whenever it has been odd number of ones means output going to be 1. So that is nothing but odd one detector. Now you can apply input over here. For example, I will apply 0 and 1 0 1. You can see output has to be 1 whenever you are applying some input. It depends upon the present inputs only. So that is nothing but combination. For example, if you are applying 0, what going to happen, already one of the input is 1 over here, so this will come as a 1. So you see you are giving OR gate, you don't want to bother about anything. One of the input is 1 means OR gate, what going to happen, it don't want to check another, because at least one of the input is 1, so output will be 1 only. Okay, so odd one detector, if you provide 1 0 also same like this only happening. Here 1 will come, so that if you are provide 1 1 over here, so you are providing 1 1, what going to be happen, A also 1 0 will come. You know that AND gate operation what going to happen, if at least one of the you want to disable means what, you need to provide some input 0. Already you are giving 1, so through this NOT gate it is going to be inverting, so you will get 0. Defaultly what is the operation of AND gate, any one of the input is 0 means it is going to be 0 only, so our output is 0. So inside this functionality will going to be happen. I need to use this XOR. For example, I am going to be see XOR. For example, you can see this is a operation A B bar. I need to use this as an inverter. For example, buffer as an inverter. So now what going to be happen, I need to use it as an inverter. So what can I can able to do means, so for example, if I am providing as some input, so what going to happen, 0 I am providing, 0 means what going to happen, 0 bar means it is going to be 1 into B plus A into 0. Already we are providing A is 0, so if I want to use this as in a buffer, I can able to 0, so that what going to happen, I will get B only. If I need to use it as an inverter, what going to happen, I will use 1. So if you are using 1 now, this is going to be 0 now. A bar will going to be 0 if you are using one of the input. A is 1 means what going to happen, 0 into B 0 only. So A means what you are used 1 you used B bar, so you will get B bar. So you are using this XOR as a buffer. Okay, so this is the thing you are going to be known about this. So you know that this is an odd one detector. Whenever we have odd number of ones, the output going to be 1 only. Now we are seeing XOR gate. XOR gate is nothing but what going to be happen, this is reverse of that. Okay, whenever it has like equal like it is going to be compared like that. Okay, for example AB 00011011. so whenever there is an equal like A equals to B, so whenever we have like both the inputs are same means then it is going to be 1. Okay, 0 0 1, this functionality inside will be there, A bar B bar plus AB. Okay, if you are providing for example 0 0 you are providing, so 0, so this will what going to happen, 0 means 1 1 you will get 1 only. So like this, 0 1 means 1 0 means like 1 1, now what going to happen, this becomes 0 and you will get 1. So this is nothing but XNOR operation. Okay, now you can use this as an inverter or buffer also, this also same. Like if you are provided reverse of that, you have provided to make it as a buffer, you provide 0, this is the inversion of that. Okay, so XOR is nothing but inversion of that. Here it is going to be odd, whenever odd number of ones it is providing 1, but it is a different to that. Now what going to be happen now, so here you are observing over here, so I need to use this as a buffer means what I need to do means I will give it as a 1 because I used, we know that A bar B bar plus AB. So if I am providing one of the input as 1, so what going to happen, this 0 entire thing will going to be 0 only, 1B. So you can use this as a buffer. If I want to use inverter means I can able to make one of the input as 0, so that you will get it as an a buff inverter. Okay, so you can able to use as an inverter if you are using like if you are using this thing, like you can use this as an inverter if you are providing 0 and B, so you will get B bar. If you check once here, A B bar plus AB, so if you are providing one of the input as 0, 0 means 1 only you will get. Okay, if you are providing 1 only you will get B bar plus what going to happen, one of the input you provide 0 into B, so you will get 0 B bar. So what going to be happen, output will going to be get B bar. So this is nothing but XNOR operation. So we have universal gates. In universal gates we have NAND and NOR gates are called universal gates. NAND and NOR called universal gates. How NAND means what going to be happen in NAND, so reverse of one AND gate and followed by a NOT gate. This is nothing but for example A into B, so YE, so what going to happen, 0 1 1 0 1 1 and operation Y going to be happen 0 0 0 1. So but what going to happen, we here one NOT gate, so 1 1 inversion of that gate. Okay, so NAND gate will be represented in this manner. If you are providing 0 0, at least one of the, if I need to disable the gate means I will provide 0, say then always output going to be 1. If I need to enable the gate means then I need to give input as in 1, so that what going to be happen, if I have control input, so I can able to give 0 means default the output of the gate is 1. If I am providing and control input is 0 1 means what going to, based on the inputs you have been provided over here, so 0 0 means 1, based on that you are going to get the output. Okay, that is nothing but NAND gate. Why we are calling this as an universal gates means we can able to implement any digital circuit. For example, I don't have any basic gates with me, I have only this NAND gate, so I need to use this as an inverter. How I can able to use this as inverter means I can able to connect these things A, so we will get A bar. So what going to happen, A bar we will get, we can use this as a inverter. I want to use this as a buffer, so what going to happen, I will use another NAND gate, I will connect like this, so A, and what going to happen, A bar will come, again it will go, we will get A. I need to use this as an AND gate. AND gate is nothing but AB. So what going to happen, whenever you are providing AB means you will get AB bar. So if you are giving this thing means you will get AB. So what going to happen, this is like I am using AND gate. I don't have any gate. I have only one NAND gate. From those gates, I am going to be using AND gate. We can also use OR gate. If you want to design OR gate, means you can able to design in this way. Okay, OR gate I am going to be designing. So how I need to get A plus B. How I can able to realize from this. So what going to happen if I have NAND gate now? So I can able to give this is for NAND, and I can able to give this B. So what going to happen if you are I am providing one more NAND gate. So what going to happen, A bar going to become B bar going to be come over here. So what going to happen, A B whole bar now. Now what going to happen, A plus B we will get. So this is nothing but OR gate. By using NAND gates we can able to implement XOR gate and XNOR gate. If I need to implement XOR gate means A bar B plus A B bar. Now what going to happen, A bar plus B bar we can able to take common according to distributive law, and A plus B. Now what going to be happen now, if you perform this thing, see we will get same operation only. Once you will check, so you will get same operation only. So if you are doing like this now, for that one AND gate is required to do multiplication with that x into A plus B. What going to happen, one AND gate XA plus XB. To implement this I need 3 gates. Total 4 gates is needed. To implement this I need 4 gates. 4 NAND gates is required. To implement I need to invert now. So what going to be happen, I need 5 gates to implement this XNOR. So these are nothing but universal gate. NOR also same like that only. So you can see NOR also. So if you are seeing NOR also same like that only. If NOR now, what going to be happen, this is the symbol of NOR gate. Okay, there A B, just it is equals to R plus one NOT gate. Okay, so if you have an OR gate and one NOT gate, what going to happen, A B and A plus B whole bar we will get. Okay, A plus B whole bar. So this is nothing but OR gate. If you are providing A B Y 0 0 0 1 1 0 1 1, as I already take 2 switches means I can able to 4 combination. So what going to happen, OR operation now. So 1 1 1, you are going to be Y of NOR means, so what going to happen, this is OR, this is NOR. See inversion of that. Okay, 0. At least you want to disable this gate means you can able to provide control input as a 1. So for example I have this NOR gate. So what going to happen, this is my control input. If control input is 1 I provided means my defaultly output of the NOR gate is nothing but 0 only. So that is nothing but if you control input, if control input is, what going to be happen, 0 means based on the input you have provided the output going to be come according to that. All the gates follows associative law and commutative law except these things. What NAND and NOR only we cannot able to get. What means we cannot able to follow the associative law. Why means you can observe that associative law for NAND gate is nothing but what going to happen. Associative law means A into B C equals to A into B into C, like this. What going to happen, if you are providing some input like A equals to 1, B equals to 1, C equals to 0. Now what going to happen, if you are providing one of the input to the NAND gate is 0 now, output going to be 1 only. So 1 into A already 1. So now what going to happen, A B if you are providing 1 1, so what going to happen, NAND gate it is going to be 0. 0 into C is nothing but 0. So 1 not equals to 0. So here it is in failure. So it does not follow associative law. Same NAND also it does not follow associative law. Okay, associative law it does not follows the associative law. Okay, so this is NAND. NOR also will not follows. Remaining all gates like AND gate, OR gate, what XOR gate, XNOR gate, this and all can able to follow the associative law as well as commutative law. Okay, we can able to, for example, if you are providing some inputs OR gate, you will provide here like this also, no problem. A plus B equals to what going to happen, b plus a you can able to write. Okay, so if you interchanging the inputs also, no problem, we will get the same output. But here it will not like that. If you interchange the inputs according to associative law, it is not able to follow the associative law. Okay, but it can able to follow commutative law. So that is the thing. This why we are calling this as an universal gate. These are not only this as an universal gate, we have some mux also. For example, I need to implement by using mux, what I have to do means I can able to implement one NOT gate. How I can able to implement one NOT gate means, these are my select lines. Based on the select line, it is going to be act as a switch. If I am selecting 0, now what going to happen, it is going to be select and it will drive. So why, if it is s equals to 1, now what going to happen, it will drive and it will move like this. So we will get in this manner. For example, if s equals to 0, what going to happen, 0 now it is going to be select, y equals to a we will get. If it is 1, now what going to happen, b is going to select, y equals to b we will get. So I need to use this as an inverter. How I can able to use this as an inverter means, I can apply s equals to some input a I am using. So what going to happen, if I am using input as a over in selector line, what going to happen, a bar into 1 I am giving 0 here, a bar into 1 plus a. So then y equals to, I am using, if you are applying any of the input means, you can able to use this as an inverter a. Okay, a bar you will get a into 0. So y equals to a bar. You can use this as an inverter. You can able to use this in a AND gate. How I can able to use this AND gate means, I providing select line as a and I am going to be b. So I am going to be what, I am going to be 0 over here and I am going to be b. So y equals to a into b, because what going to happen, if select line is 0, now what going to happen, it is select. So 0 plus what going to happen, a into, it is going to be select a into b. So we will get ab. So like this, not only this NAND and NOR universal, but we can also say mux also an universal gate, because we can able to implement any of the gate by using this mux also. For example, not only this thing, you can observe this thing also. For example, if we have like this also, we can say this is an universal gate. Okay, because a b is there with me, I need to implement a b bar, this is functionality, but I don't want, I need to, from this gate I am going to be implement any basic gates, then I can able to say that I can able to realize any digital circuit. For example, here a b is there, so I can able to use two gates over here. Now what going to happen, another gate I am using, so I need to get a. So what going to happen, b bar I will get. So b I am giving b bar, so you will get 1 over here. So now what going to happen, you are providing this as an input. So what going to happen, this b bar will goes over here, you can observe this. And what going to happen, b we will come, we will get b here a. So a b we are getting. So this is nothing but universal gate. So NAND, NOR and some other like this type of gates also, we can say this also universal gate. MUX also an universal gate. Okay.